Hello. This video will be a kind of response to a video that the YouTube channel Mind Your Decisions posted. So I will show you the problem. So you have to find out the length between the points B and C with just those angles given at the point A. There will be 60 degrees, and also you can you know the length between A and D. This will be 100, and the length between B and A, this will be 2 times the length between A and C. So now you know the problem. I will give you the link to this video in the description. Alright, so I will show you a very easy and intuitive way to solve this problem. So let's start. I hope everything is working. So at first, if we have those angles, phi, this will be 60 degrees, or pi over 3, I think. So let me think about this. Pi is 180 degrees, so pi over 3 has to be 180 divided by 3 degrees. This should be 60. So let us at first have a look at a triangle with a length of 1 at the long side and with an angle phi here and phi over 2 here. So phi will be our angle pi over 3. So this length will be cosine of phi, and this length will be sine of phi. Okay, let's call this y and this x. So if we draw another triangle with an angle phi over 2 here and phi here, also length 1, then this will be cosine of phi over 2, and this will be sine of phi over 2. But since those triangles are like almost identical, just flipped over, we know that this length has to be y and this has to be x. And with the identity for sine of phi, which is just 1 over 2i e to the ix minus e to the minus ix, which is nothing but 1 over 2i e to the ix over 2 minus e to the ix over 2. Why do I call it x? It's phi, okay? Sorry for that. Okay. And 1 over 2. And of course, then I have to say it's like 2 times this quantity. E to the I phi over 2 plus e to the I phi over 2. And I forgot the negative signs here. And since we know this has to be sine of phi over 2 and this has to be cosine of phi over 2, the whole thing will be 2 times sine of phi over 2 times cosine of phi over 2. And since we know this guy is y, and those guys or girls are 2 times, let me have a look, x, but x is nothing but cosine of phi, and cosine of phi is 1, the square root of 1 minus sine squared of phi, but sine squared of phi is just y, so we have the square root of 1 minus y squared times cosine of phi over 2, this is just y. So now we know that 1 has to be equal to 2 times the square root of 1 minus y squared. And now we can solve this whole thing for y. I will just erase this. So this is the only quantity we care about. Upsala. So 1 over 4. So let me just square the whole thing and bring the 2 to the left side. We have 1 over 4 is equal to 1 minus y squared. And now we will bring the y to this side and the 1 over 4 to the other side. So I will have y squared is equal to 3 over 4. And now we know y will be just square root of 3 over 2. Okay, so this is sine of pi over 3. So sine of pi over 3 is just square root of 3 over 2. And since cosine of pi over 3 is just the square root of 1 minus 1 minus sine squared of pi over 3, we know that this will be 1 over 2. So you can just you can see this very easily, because if you square this, you will have 3 over 4, and 1 is just 4 over 4, so 4 minus 3 is 1, so you will end up with 1 over 4, the square root of the whole thing, so this will be 1 over 2. Okay, now we know something about our angles. And now let's just define something. this D will be our origin. So I will call it 0, but never mind. And we will introduce another angle. We'll call it theta. And we know that AD will be 100. So we will call this R. And we will call this whole vector R times ER. So the vector AD, let's just call it AD vector, is equal to R times ER. This vector 2, so everything is fine, but ER will be nothing but R times some rotation matrix D times EX, and this rotation matrix, I don't know where I can write it down, maybe here, D will just be cosine of theta, sine of theta, minus sine of theta, cosine of theta, and also we will call those ER, and this vector will be E theta. Alright, this is just a rotation matrix, everything is fine over here, so EX will be mapped to ER and EY will be mapped to E theta. Okay, so now let's just focus on those two lines. We will define two curves. One will be called gamma minus and one will be called gamma plus. And gamma plus will be dependent on T plus. And gamma minus will depend on T minus. Hi.
Hi, Stellmutter. Sorry.
Okay. So, yeah, they kind of interrupted everything. Alright, so what happened? Okay, we wanted to define gamma plus and gamma minus. So gamma plus minus of T plus minus will be defined as, of course, AD, because we want to start at this point over here at A, because the vector AD will end at A. Okay, so then those guys just interrupted me, so let's just focus a little bit. Okay. All right, I know. now I know what I wanted to do. So okay, so this will be okay, we will start at A, and now we want to add another vector, and this will be t plus minus times the derivative of gamma with respect to t plus minus, but this won't depend on t plus minus, so I will just leave it like this. Okay, and now we want to flip this whole thing to the x-axis, and let's say let's continue here. If we take this and transpose the whole thing, we'll get the inverse rotation, and we say that d inverse or transposed of gamma plus minus of t plus minus will be, okay, if we take the inverse of ER, we will end up at EX, so R EX plus T plus minus D inverse gamma prime plus minus. And now we want gamma prime to have the length of 1. So we know that this is R times EX, so this will be R, and we will end up right here. And we know we have to take those two lines to get our gamma prime. So with a length of 1, this will be dt gamma plus prime, and this will be dt gamma minus prime. Okay, and now we can construct those two vectors. So this will just be like standard polar coordinates. So we have minus cosine of phi and plus sine of phi for gamma plus, and for gamma minus we have minus cosine of phi and minus sine of phi. So now we know, since we computed cosine and sine of phi, this will be just 1 over 2 1 square root of 3 and minus over there, and 1 over 2 with the minus over there, 1 square root of 3. And now we know gamma prime, because now we can just take d times those vectors, d times d transposed will be the identity, and so we will end up with gamma prime. So we can write it down. This will be AD, of course, plus t plus minus over 2 of, now this first entry will be correspond to Ex, this will correspond to Ey, and Ex will map to Er, and Ey will map to E theta. So we will now have, we'll just let's bring out the minus to the front. 1 times Ex, Er, sorry, and now minus plus square root of 3 E theta. I hope I got everything right. Let's just check. Minus this, plus this, and minus minus, minus minus. Okay. Okay, now we know our curve, or both curves. So what's left is to compute something. So at first we will just know something because we want the gamma minus to cross a line at the x-axis at the point C, and the same over here with the point B and with gamma plus, of course. So we will call this x plus, and this we will call x minus. So we want x plus minus Ex to be gamma plus minus, of course, of t plus minus, and we want to solve for t plus minus because t plus and t minus will be AB and AC. So t plus will be AB and t minus will be AC. That's the point where those two lines will meet. Okay, fine. That's pretty nice. Now we can project the whole thing onto our two vectors ER and E theta. So x plus minus Ex ER will be cosine of theta. Okay, I will just write it down. So, will I write it down? Okay, let's just say projection ER. So this will be x plus minus cosine of theta, and we know the scalar product of ER and E theta is 0, because cosine times minus sine is some kind of the additive inverse of sine times cosine theta. Did I say phi? Whatever. So, okay, just compute the whole thing. I will project onto ER, so this will be R plus T plus minus over 2. Okay, and there will be the projection onto E theta, and this will be x plus minus sine of theta, and this will be square root of 3 over 2, but minus plus, no, plus minus, because there's a negative sign over there, and there's a negative sign too, plus minus. Okay, alright. Okay, we know some things. So we know that, can I erase this? I don't know. Maybe I will write down those two equations over here, because I have so much space. X plus minus cosine theta is equal to R minus T plus minus over 2, and X plus minus sine theta is equal to minus plus square root of 3 over 2. Okay. Alright. Still recording? Yeah. Yeah. Okay, I can erase this. Okay. Now we know that x plus over x minus is equal to R minus T plus over 2, or this quantity, 2R minus T minus. So, okay. But this will also be, I forgot T plus minus over here, so this will also be minus T plus over T minus. Okay, so we know that T plus will be much bigger, or 2 times bigger than T minus, so we will assume that T plus, this quantity over here, will be negative, and this will be positive. Just an assumption, so we will bring the minus to the I don't know, enumerator, or maybe that's the right word, I don't know. Okay, now we know if we like insert a k over k here, we know that t plus or 2r minus t plus minus times k is equal to minus plus t plus minus. And yeah. Okay, now we can solve for k. So k will be minus t plus over 2r minus t plus, and this will also be t minus over 2r minus t minus. And we know where those two will meet, or x plus, and this x plus will correspond to AB, of course. So let's just insert AB over here. So minus AB over 2r minus AB. Let's just call it 2 times AC. It's much easier. This will be AC 2r minus AC. Okay, now we can solve for AC. Since we can ignore this AC because it's not equal to 0. So now we know that AC minus 2r is, or no, that's wrong. 2 times AC minus 4 times r is equal to 2 times r minus 2 times AC. And now we know that 6 times AC is equal to, there's something wrong. Is there something wrong? No, there's something wrong because this is just 4. Oops. And this will be 6 times r. Now we know that AC is equal to 6 over 4 times a, and this is just 3 over 2 times r. So we know that AB is 2 times this thing. This will be 300. Just write it down there. So we're almost ready, almost done, because just have to figure out what x plus and x minus is. So we know, we want to know what sine of theta is, but we know what the tangent of theta is. So the tangent of theta is nothing but this over this. So this is minus plus square root of 3 over 2 t plus minus over r minus t plus minus over 2, and we can insert one of our lengths over here. So just take t minus will be AC, so 150, or it's also just 3 times r. So let's say this is 3 times r, just a positive thing. This is r minus I want to, so let's just take the AB length. So T plus is 3r in this case, so here will be 3r. Of course, this will be 2r over 2. This 2 will cancel with this 2, and here will be a 3r. So this will be minus 1r. So we will cancel this r over there. So we will end up with 3 times square root of 3. Whew. Okay. But we also know, since we know what cosine is, of course, is 1 over cosine squared of theta equal to 1 plus tangent of theta. Theta. And this is nothing but tangent squared of theta. So this will be 3 times 9, which is 27. So this is 28. So cosine of theta, and theta will be less than 90 degrees. So it will still be positive. So cosine of theta will be 1 over the square root of 28, but 28 is of course 4 times 7. Yes, so this will be 1 over 2, 1 over square root of 7. And sine of theta, of course, is just square root of 1 minus cosine squared. So, too much work done over here. So this will be like 1 over 28. So this will be 27 over 28 and the square root of the whole thing. The square root of 27 is 3 times square root of 3. Am I right? I hope so. 2 times square root of 7. Okay. Am I still recording? So who cares? Now we know sine of theta. We'll just leave it down here. Pretty easy solution. We'll erase this piece over here. Okay. Let me think. So we want to have x plus minus x minus, which will be BC. That's the length we're searching for. And BC, if we take this equation over here and insert AB and AC here, we will get, of course, 1 over sine of theta, and then x plus minus let's bring it to the front, square root of 3 over 2 minus, no, I've done something wrong. I called this x minus, but we computed this as this where x minus this is x plus, this is x minus. So sorry about that. Okay, again, x plus minus x minus will be, so x plus will correspond to t plus, okay, and t plus is, no, of course, now this has to change, so x minus minus x plus, since x plus should be negative and x minus should be positive. Okay, again, so we will have plus square root of 3 over 2 t minus, and t minus is AC. So 150, I think. And we will add some nice value to it, and we will call it 300. or maybe we'll just call it, yeah, or let's just insert the values here. This will be fine. So sine of theta, we see that this and this will cancel out, and we will be left with 3 and 7, but this is nothing but 3 and square root of 7. This is nothing but 3 times 150. So let's just insert the whole stuff here. We'll bring out this 3 to the front, and we will insert sine of theta. So 3 times square root of 3. And here we will have 2 times square root of 7. We're left with 150. We can cancel out this. And we have our final solution after a long time, because we chose the easiest way, square root of 7 times 150. That's the final answer. And of course, this is the same answer. Mind your decisions. God. Of course, it was hoppy hop, pipapo. And now we can see that that's the same. And he just explained it in like 4.5 minutes, and yeah, and so on. So have a nice evening, and we will see us maybe in the next video, maybe not, nobody knows.